outset, let me introduce, like I said, I lead a team here in interactions. I work on language technologies for customer care, involved in this area for a long time, and wanted to share some of my thoughts on where language technology can help and, the opportunities and challenges that we see. Most of you are in the language program, so I'm sure you'll appreciate it. So what is a contact center? Most of us have experienced it personally. It's any place where any business does any kind of product or a service. They need to set up a contact center so that, they address some of the challenges that their customers have. And believe it or not, it's a $500 billion business. It's an enormously large business. This is an annual spend across the world. So you may ask, what exactly do they do? What do these people do, right? And, they're world over. The contact centers are set up in India, in Philippines, in Mexico, and in the US. And so what exactly do they do? So I'm sure each of you have called for one reason or the other. And typical reasons could be, answering questions, information questions, getting some resolution on your billing problems, some issues about your credit card statements or what have you. You have technical assistance, router setups, or your iPhone not connecting to some other device or what have you. And of course, scheduling appointments and reservations, right? You call for, a doctor's appointment, or call for reserving a hotel or an airline or whatever. So there are many different these issues that get resolved by these folks who are sitting on the other side of the world sometimes, and they resolve these issues by taking your phone call, by answering your chats, by answering your emails, and so forth, right? And there are different types of call centers. I mean, you probably think about it as the inbound call center where we call in, which typically is the bulk of the call centers that traffic. But there are outbound call centers too. That means there are call centers that make proactive calls out to your phone. And nowadays, I'm sure you, like me, have receiving a lot of spam calls. They're basically outbound calls made from various places, trying to sell you something or trying to get you to do things, or genuinely, when there is collection issues like bills have to be collected, there are outbound calls made saying that you've not paid your electricity bill or telephone bill or whatever, right? But there are, automated versions of it. It doesn't have to be just human driven calls. And post-COVID, you have virtual call centers. Typically there used to be office-based call centers where people would go in and sit at a desk and take calls and so forth. But after COVID, it has been virtualized, which has its own implications, and I'll talk about that in a bit. So you might wonder, what kind of distribution of calls or distribution of contacts happen, right? While we all might think that, well, we are moving to a text-based, SMS-based, chat-based contacts, it's still the case that the phone calls dominate. About almost 55 to 60% of the calls or contacts are through phone. That means voice is a pretty central channel to communicate with the contact center agents. And invariably, folks want to, pick up the phone and call because they expect a human voice to resolve that problem that they want to get it resolved. There are new media like social media where they post something on Facebook or a messenger, and then call center agents are monitoring it, social media agents, and they try to resolve that problem that has been posted or grievance that has been posted on a private messaging channel, like a direct message channel. And so that's an emerging, but still dominating call centers are, phone calls. So you might wonder, where do these things start off in terms of distribution across the industry? Dominant is the financial services, perhaps because money matters are so important. Or it could be that things are not automated as, web transactions that invariably try to chat or call financial services the most. The next up are consumer services, like retail and so forth. Services sector, which is hospitality, like making reservations to a hotel, or travel agencies and stuff like that. Technology and media, which is or telecom, that's another big one. You're signing up for services of various kinds. Your phone is not working, your new plans or what have you. Life sciences, healthcare, making lab appointments, talking to a doctor. These are all other parts where you see contact center traffic coming in. And of course, utilities and energy, like your electricity bills and your telephone bills and so forth. I'm sorry, there is people vacuuming outside that makes it sound bad. They'll go away in a minute. All right. I wonder what kind of statistics do agents, sort of encounter. So here is a bunch of things. You might say, well, how much do they get paid? It's about $25 to $60 an hour, depending on where the contact center agent is. This is, of course, on the US soil. Now, if you export or outsource it to places with a cheaper labor force, that can drop down to about, $15 an hour or, even $10 an hour. But it's the turnover rate is really high. That means the burnout rate that these agents encounter is pretty large. The impact of that is that you have to train these agents to take these calls, and it takes 3 months to train them before they're ready to take calls. And so if 30% of your trained employees are going away, that's a phenomenal wastage of your, capital. And the agents are handling about 9 calls an hour. It takes about 7 minutes a call. But if you fold in all of their training time, their downtime, the lunch time, the break time, and so forth, it comes down to about 60% of the time is really spent on a call, right? And there are 18 million agents globally. So that's a phenomenal workforce. Globally, they're spending taking calls. So there's a ripe opportunity here to really upset this market. And give it a minute. Let's see if the vacuum guys go away. Okay. So, as I was saying, that these virtual and office-based call centers are changing the way work is being done. And people now can work from home. They don't have to go to offices. Across the globe, you can recruit people. They can be sitting in their living room or kitchen and whatever. And the implication is that the security aspects of it, while it was easy to control the workforce when they were coming into a building, and you could control the security of that building. Now that the labor is distributed all over, it's the credit card number that you give, or the social security number that you give might end up in somebody's living room. And so there are tangible implications of this, and we'll talk about that as well. So metrics for a contact center, you might wonder, how do you measure how good a contact center is? And because, customer experience is sort of the front and center of every brand. Besides buying a product, whether it's your iPhone or booking a nice vacation somewhere, it's how that company interacts with you makes or breaks a business. And so contact center is front and center and very key to the operations of the business and the user experience that they deliver. So there are a number of metrics that folks track in a contact center. How quickly did you respond? How long did it take to reply for, and how long were you waiting in the queue? Most of us have had experience waiting for, upwards of 30 minutes on a call, just waiting for an agent.
All audience members, please mute, except for the speaker. Hold on, I think.
Right.
I think I muted. Go ahead.
Yeah. So one important tracking metric that people track is the first contact resolution, which is, I called the contact center the first time. How was the resolution? Did I have to call back to resolve my issue? And oftentimes the satisfaction goes down if you have to call back to resolve your issue, right? Resolution rate, how successful are you resolving in many issues that are coming into the contact center? What is the average handling time? How long did the agent take to solve that issue? And agents, of course, the faster you solve that issue, the more calls you can take. And of course, tracking top agents and trying to use them as coaching for other agents so that you have top performers in the contact center. Net Promoter Score is another metric that people track, which is to see if these customers become promoters for their brand, for the customer, for the company. And of course, the CSAT score, customer satisfaction score, that's a big deal. Oftentimes reviews are sent out to see how people feel about it, but oftentimes the folks who respond are folks who actually complain about their experience, not the kinds of people who are really satisfied, not positive feedback, right? So usually about 10% of the reviews come back, and most of them are complaints. So these are some of the metrics of a contact center. Okay? So behind the scene, you might wonder what exact technology is used in a contact center. So when you call, you're basically coming in from a PSTN network, which is a telephony network. And when you place a call, you're going into what's called an ACD. ACD is a automatic call distribution. In the old days, it used to be called PBX, right? And it's a way to do routing of the calls. Think about it that way. Now, there are a bunch of agents who are sitting behind it. These are agent workplaces. There is a supervisor in every contact center managing the bunch of agents. A bunch of databases, which allow them to track the customer management, databases related to the back office information, what services you have subscribed to, what was the previous conversation about, and things like that. And there are aspects like the, computer telephony interface that allows you to bridge between and route traffic between agents in case you have to be transferred from one agent to another. There is also IVR, which is interactive voice response system, which is basically an automated way when you might have encountered press 1 to do this, press 2 to do that, and so forth. So that's part of the contact center. So that's your PSTN or telephony channel. There is an equivalently similar, email and web server channel that, when you place an email or do chat over a web portal, it goes through the similar sort of infrastructure. And these are typically on premises, sometimes on premises meaning physically located. Hardware is located on premises, and it may be distributed in various parts of the world, but still they're co-located with the agent. The hardware is co-located there. More recently, contact center is being distributed as a service. You might have seen Amazon Connect, Genesys, and others who are presenting contact centers as a service where you can sign up for various aspects. You don't have to own the hardware anymore. It could be in the cloud. So like everything else, we're moving contact center also into the cloud. And that gives, flexibilities and so forth. Advait, how much time do I have? I forgot to ask.
We have a full, the class period is until like 4:10, but I would aim to maybe end your talk like around 3:45, 3:50 to allow time for questions and discussions.
Okay, so I have about 35 to 40 minutes.
Yeah.
Okay.
Okay.
Great. Okay. So now the question is, you all are wondering, okay, now I know about contact centers, where can speech and language really help? Right? We all work on speech and language. So where can it help? Obvious things are call routing. So if I call into a contact center and say, well, I'd like to purchase a new iPhone, that's a sales call. And there are, sales agents might be best to handle that. While I might call in and say, my iPhone doesn't seem to start up, that is basically a technical assistance call, and maybe you have to route it to an appropriate agent pool who know technical assistance, right? Or, you charged extra for whatever, service that you've subscribed to, and that could be a billing and payment issue, and that could be a place where you route the call to. So call routing is pretty common, and one can go about extracting more information before you route the call. What's your name, what's your account number, what's your, authenticate the user, and collect basic information before you route the call to an agent. Then there are agent assistance technologies that language and speech and language technologies can provide, where the agent has a desktop in front of him or her, and you can provide tools and techniques for upselling and cross-selling. That, you just bought a pizza. Hey, how about suggesting a drink or a dessert along with it, right? So that's called upselling. And of course, emotion detection. You can suggest de-escalation strategies to the agent, saying, hey, look, the customer is really upset, try to de-escalate, try to soothe it out with an appropriate prompt and suggest certain things on the agent screen to help them de-escalate the situation. There is post-call analytics, which is you collected the data, the conversation has been collected. Now the question is, what can you analyze? And we'll talk about that in a bit. What can you analyze from that and do better next time, or provide information to the business? Then there is, of course, intelligent virtual agents, which is to automate as much of the call as possible. Maybe you don't need the agent at all for the call, because it's, information question that, an FAQ can answer it. And language translation, where the speech is coming in German and the agent is in English, and you can translate it and make the agent understand what the German user is saying, right? So those are some use cases. There are plenty of other things like summarization, question answering, and so forth that one can bring into the fore here. But, as much as AI is something that everybody wants to do, chatbots have not really succeeded in the last several years. Several failures have been reported in the press, and people are really concerned about investing in AI for these reasons, right? So it's not a given that AI can help out call centers, right? And you might have seen, all of the technologies that you all are learning, and you probably have read in the press. Conversational AI technologies is a complex object. It's not a single piece of technology. It's an ensemble of technologies that have to play well with each other. Speech recognition, language understanding, biometrics, dialogue, text-to-speech, all of these have to play well together to have a unified and fruitful experience. So we'll touch a little bit on each of these, but I wanted to give you a little preview on the evolution of the industry itself. I mean, it's not like contact center and applications of AI and contact center just started recently. It goes back a while back, where we used to have very simple commands in the early days, to help out, in a sense. Simple keyword spotting, where speech recognition was not really perfect back then. Isolated words that would help route the call to an appropriate place. And then slowly in the 90s, when speech recognition became a little bit more sophisticated, we could understand things like collect call, operator services, enterprise services, and so forth. So we could offer more richer sort of how may I help you prompting without having to say predefined keywords, right? And you could now express yourself as, I have a problem with my bill, and it would automatically route it and perhaps even collect some information. What's your account number, and so forth. Right? And that was later in the late 90s and early 2000s. Right? About 10 years back, there was a sea change, in the sense that we started building out dialogue systems that are far more sophisticated. We could integrate it with a lot more services, so we could do more richer conversations, and also do proactive systems where the system responds to you and say proactively, your traffic on this route is high. Would you like me to reroute you to given that your meeting is going to start in 30 minutes, right? So those are, opportunities that came about because we figured out how to integrate various knowledge sources, information sources, and into a dialogue system and provide that sort of rich access. Along the way, one theme that stood out is that as the years went by, the computation became cheaper, data became more available, and also the software that we started using, there was more access to open source software. In the early days, it used to be very proprietary software with an IBM or AT&T or Microsoft, but increasingly you see open source software that is available for many of these technologies to be built by smaller companies. Now, speaking of conversational technologies, this is sort of a caricature of the evolution, and some of it you probably have seen in your course material. the early 60s and 70s, things were dominated with formal grammar, with rule-based systems. And we started building out linguistic grammars, computational grammars in the 80s and 90s. And these are essentially rule-based systems. It took a lot of analysis to come up with these grammars. And subsequent to that, as data became more available with the advent of internet and World Wide Web, right, we started building more data-driven models, right? So the discriminative models in the 2010s, but before that, generative models, like providing, probabilistic systems, statistical systems. And more recently, of course, DNN-based models, which are more nonlinear in nature, and given the fact that we have access to increasingly large amounts of data. Right? But in addition to that, all of this was sort of facilitated by the rapid decrease in storage costs. Right? You could buy terabytes of disk space, previously only imaginable in the 70s. And simultaneously, the price of computation, the amount of computation for a given unit price really skyrocketed, and so much so because of GPUs, you see the large scale models that we can build since 2015, 10, right? So now, however, the dependency on data also increased. As a consequence, you see most of the cost in building models shifting, not to computation or storage, but more for data annotation. And that's something that, every company that does machine learning based language technology has to face an annotation cost. Okay. Let me switch gears a little bit. Maybe I should pause to see if there are any questions. Any questions about?
Any questions for the speaker? No?
Okay.
Yeah, no questions. Go ahead.
All right. So let me, continue on. So let me give you a little bit of speech recognition. Some of you may know about it, some of you may not. Traditionally, a speech recognition system is a combination of three different components: an acoustic model that maps audio into phonemic units, a pronunciation model that says, how do I stitch those phonemic units into a word? So that's basically a tomato kind of distinction. And then a language model that tells you how to stitch those words together to have a syntactically well-formed sentence, right? And the likelihood of that particular sentence happening, right? So those are the three components that typically are built out. An acoustic model is typically built out from a pairing of audio with its transcription. A language model is typically built out by taking a large corpus of text that's relevant to a particular domain. And a lexicon is a manually created resource. Sorry, they're doing some office cleaning here. So just a second. The meeting, did they not do that? Sorry about that. A language model is, typically built out using a large corpus of text, right? But more recently, there is a class of models that we are starting to build out, which have been deployed very successfully, which are called end-to-end speech recognition models. Instead of these three components of acoustic model, pronunciation model, and language model, we are going directly from audio to the text without having to compartmentalize it. Now, what is the opportunity here? We can optimize the whole network end to end and create a speech recognition system that directly optimizes the end result, right? Without having to go through the three steps in compartmentalizing and error propagation happens in that compartmentalization, right? So all of those opportunities go, disadvantages go away, and they're folded into one single network, and you can optimize it on GPUs with large amounts of training data here, right? Now, what about spoken language understanding, right? So yes, you got your words, you got confidence scores on these words. Eventually, what drives a conversation is the semantics, is the meaning that has to be extracted out of these hypotheses or the transcripts that come out of speech. Now let's look at various grades of spoken language understanding. So a simple one, like routing applications, like I mentioned to you, is spam detection or a sentiment detection, and in simple classification. So I give you an utterance, like I'd like to make a collect call, or I'd like to purchase an iPhone, and I need to understand what kind of intent you're expressing. Is it a sales call or a technical assistance call or something like that? Okay. There is, subsequent to that, and getting some richer semantics out of it, you might want to know what specific entities are being mentioned in the spoken language utterance. Like in this case, I'd like to make a reservation at a Hotel Commonwealth for January 29 for 2 nights. There are a bunch of elements of important information, salient information that needs to be extracted to make this reservation. So we need to extract all of that so that the dialogue system can act on it. Okay? So those are, also called the frame-based approach, where you have frames that have to be filled out, and you have to extract that information out of the speech recognition output. Now, subsequent to that, in a more sophisticated system, you might have multiple intents, multiple requests that are happening in a single utterance, right? So you might be ordering something and you're asking for some information, and you have scope aspects, like some frames have to be filled for a particular intent, and some other frames have to be filled for other intents. And all of this has to be done pretty robustly, independent of the speech recognition errors, right? So it's not just a text to frame semantics. It has to go from speech recognition output to frame semantics, right? And increasingly, what we are seeing is that technology has caught up to a point where we could not just do end-to-end speech recognition, but we can actually do end-to-end semantic extraction. So you could, if somebody says, my telephone number is XYZ, I can extract the entity in there directly from the audio without going through speech transcription because of these end-to-end stacks. Right? Now, one aspect that perhaps is not always clear is that in these contact centers, enterprises' business keep changing pretty dramatically all the time. And either new services get introduced or new business, semantics get introduced because the business decided to offer a new service to a new segment of the population, right? It could be, you are a non-governmental organization and you are exempt from taxes, for example. And so these are cases in which new semantics, new meanings have to be extracted, and that has to be done pretty dynamically. So these models have to be updated very, very frequently. It's not a static, build it once and forget it kind of approach. So in that sort of scenario, what becomes important is the notion of few-shot learning, right? How quickly can you retrain the model? How quickly can you adapt it with very few examples, of the new semantics that has been expressed in those few examples? And that's a important challenge, and many researchers are working on that. As you know, the large language models have taken us ways out. In fact, some of the things that I'm going to be talking about and at interactions, we do quite a bit of that. So let me transition to that. Interactions is a managed customer care business where we build out applications, end-to-end applications. We build out the dialogue. We have the technology of speech recognition and natural language understanding. But most importantly, when the technology is not confident enough, instead of annoying the user and saying, well, can you please repeat that? I didn't get your name. And, they get hyper-articulated and they get annoyed, and speech recognition goes into a death spiral, so to speak, and annoying the user even further. We use the confidence value to say, well, we're not confident we got it right. So we pull in agents, and we call that human-assisted understanding, in real time to nudge the technology forward. Basically to say, well, this was what the user said. It was John Smith. So independent of the acoustic environment, independent of the noise behind, the speaker, it could be a child crying or a telephone or a TV blaring. When those conditions happen, we have human assistants come into the picture and help the technology forward by relaying what the user said without having to annoy the user. And a consequence of that is that we get supervised annotated data through this operation. So if the business changes its semantics and we don't have a model that can recognize that, we can reject based on the confidence score and say, well, let humans tag it for a period and get the tagged data and build out the model for the subsequent deployments. So this way, we are sort of constantly annotating data, especially when new products and services are released and new business intents are created. Okay. So let me talk about dialogue management. So flow-based dialogues, which are basically linear dialogues that people design essentially by consent with the engagement of the enterprise, figuring out, what kinds of information should I extract from the user so that I can hit a back office service and, accomplish a reservation task, for example. Let's say we're doing a hotel reservation. There is a linear flow of the pieces of information that needs to be extracted, location, check-in date, check-out date, and so on and so forth. And once I've extracted all of that, I can hit a back office database and see if there is availability on those days and come back with further prompting. So this is a very controlled way of designing a dialogue. It's usually done with the close collaboration with the enterprise because they want to make sure that their brand is well represented in the dialogue. Right? There are also, frame-based or slot filler dialogues, less control than the flow-based approach, where the user might say, I'd like to make a reservation for 3 nights at the Hyatt in Los Angeles, arriving on December 26th or something like that. So multiple pieces of information. And this results in a slightly non-linear dialogue, not as linear as the flow-based one, right? And there are knowledge graph-based dialogues where there may be a menu, right? There's a menu of in a pizza restaurant or something like that, and a very structured way of navigating that menu, and that results from just traversing the menu in a very structured fashion, asking the right prompts at the right places based on the choices that are available in that menu. And finally, more recently, we see end-to-end neural models where the speech recognition or natural language understanding and the generation components are all blended together into one single neural model to optimize, just like end-to-end speech recognition, try to optimize across multiple components. we try to optimize across multiple components in a dialogue system. While this may be very appealing, the challenge is that commercially it's challenging to convince a brand to adopt this because they are very concerned about what the system is going to prompt and how the persona of the system comes across to the user. Because there's no control on the generation side, it might produce things that may affect the brand. And so such systems are still not deployed in production, so to speak. So challenges in a dialogue management system usually arise from the flexibility of interactions from a user's perspective. As you saw, the flow-based one may be very structured, deterministic, and dialogue designers have authored it, whereas the neural model might be very flexible, very robust in one way, but it has its own challenges, right? So in terms of functionality, what kinds of scenarios can you support, right? The flow-based one is prefabricated based on engagement with the enterprise customers. Authoring, for example, flow-based is very structured authoring, again, whereas neural models are data-driven. They can be bootstrapped from data if you have the right kind of data. There's monitoring issues. How do you monitor a dialogue system when assuring the enterprise customer that it's really working well? What are the extensibility challenges? If a new use case comes about, can I quickly adapt the neural model to absorb a new case, to adapt to a new case, and how do I do that? So those are questions that come about because business keeps changing all the time. That's one thing that's sort of universal, right? Modularity, can I piece them together? Can I take a module that does credit card capture and reuse it in many, many different cases where there is a need for capturing a credit card? There's also data availability. If there is an opportunity to collect data, realistic dialogues, and turn them into data-driven dialogues, dialogue management, that is certainly an opportunity. However, the conversations that we typically collect between two humans may not necessarily be the right kind of conversation that we can use to do a human-machine dialogue. Partly because, now that the machine is the listener, not a human being, right? So those are some of the challenges there. And as I mentioned before, branding and control of the persona of the system is extremely important for the enterprise customer. So we can't really say, well, you get what you get. Right? Increasingly, there is interest in the research community on the end-to-end dialogue management, but there is still a gap between what the research community does and what the production systems are deployed because of this expectation gap, so to speak. So a little bit on, I have about 10 minutes, a bit on the blending of AI and human intelligence. I gave you a little bit of a preview in human understanding, where when the ASR and natural language understanding fails, you could bring in intent analysts who help out discern what's being said and try to compensate for the accents or the acoustic conditions or the dialects and so forth by listening to the audio. You can take that a step further. You could take that a step further by saying, well, I will not just do the understanding part, but I will try and resolve the task that the user is asking me to solve. Right? For example, my router is not connecting to my computer. Please help me out. Now, instead of simply tagging that as technical assistance and routing it to an agent who will take over the call and help you debug, is it possible to do a task orchestration, part human, part machine, so that we could resolve the task without even escalating it to a voice agent or a digital agent, right? So that kind of orchestration, just like the orchestration in understanding happened with intent analysts, the orchestration can be taken up a level to solve the task itself. And we could break down the task and saying, okay, go and reboot your router, and all of those steps can be automated. But at times when it doesn't, fall in the purview of automation, then we bring in a agent to help nudge the technology to move forward and accomplish the task. So once again, just like in understanding components, in the task completion or task orchestration components, we can gain insights and do task mining, so to speak. And there is a whole field of robotic process automation that tries to learn patterns of tasks so that one can go about executing these tasks without necessarily involving a human agent. Right? So sort of a blended way of thinking about AI and humans. Right? So now, before a couple of slides and conclude, but one aspect that I alluded to is because of the virtual nature of call centers after COVID, people are distributed. As I said, they could be in the kitchen, it could be in a living room or anywhere in the world, and they can listen to a phone call and become call center agents. So what is the risk of that, right? The risk is basically that your personally identifiable material, like your credit card numbers, your social security numbers, account numbers, bank information, could be anywhere in the world. And that is a huge problem. In fact, one of the big customers was sued for $25 million because one credit card number was stolen. And there is a huge market for this around the world, noting down credit card numbers and selling it on the black market. So is there an opportunity here to bring in speech redaction technology so that when the customer is talking about credit card, we could identify the entity in real time and suppress the audio from going to the agent who may be in, around the world, across the world, in their living room or in the kitchen, right? So this is called real-time audio redaction, essentially protecting the customer and protecting the agent from leakage of sensitive information by using speech recognition and audio redaction technology in real time with low latency to suppress that information. And this could be applied to credit card numbers. It could be applied to, medical related information, what have you. And the information that's captured during that redaction process gets auto-populated into a payment system, and the payment goes as if the agent had input that, but in reality, the agent never hears the audio related to that. So this is a upcoming technology that people have been trying to deploy, and with the work from home call center agents, this is a huge opportunity for protecting the customer as well as the agent and, of course, the brand itself. Right. Finally, I want to talk about post-call and in-call analytics. Once you have collected the data, there are tons of opportunities to apply language technologies in there, right? So paralinguistic information like age, gender, finding out the demographics of your customer base, all of these allow you to segment, the kinds of problems that a particular group of customers might be calling about. They may be, calling about medical insurance. They may be calling about issues related to, purchase of a shoe or what have you. And there may be distinctions between these demographically distributed customer bases. And you can sort of personalize the conversation as you discern this attributes during the call itself. And emotion and sentiment, of course, we talked about that. And agent assistance, I alluded to it. Compliance statements. So there are parts of a conversation where you are required to say certain words for compliance purposes, especially when you're collecting credit card information or getting some personal information. The agents are required to read out certain statements so that the customer is informed about it. And sometimes in the flow of the conversation, they may forget that. So having assistance that reminds them, hey, look, you have to say your compliance statement is important. De-escalation strategies, emotionally charged customers, suddenly you have to de-escalate and provide them with meaningful prompts that the agent can say out, display empathy, and so forth. FAQs, obviously, a case that may have been resolved before that one can bring up onto their dashboard and say, well, this sounds like a case that we have solved in the past. We've talked about upselling and cross-selling. Churn prediction is a huge one where, if you lose a customer, to gain that customer back is a huge expense for the enterprise. So can you predict in real time during the call that this person is going to leave the company as a customer? If you're able to do that accurately, then you could have mitigating strategies that the customer agent can bring in and protect the loss of that customer for that business. So churn prediction is a big deal. And finally, dialogue trajectory analysis. You've collected a lot of dialogues. Obviously there is opportunity to do end-to-end dialogues, but more niche, you could segment it to understand, where is it that the average handling time increased, or where is it that the customer is hanging up and things like that. So to optimize the call center from a variety of different vantage points. Right. So to summarize, contact centers is where sort of language is grounded in complex collaborative tasks. And people call contact centers to resolve their issues. And so the language is not chit chat. The language is not finding, what the weather is in New York tomorrow. The language is grounded to solving real tasks and really hard and complex tasks. Sometimes, it's in terms of emergency they're calling. So you can't just simply ignore it and take it to a bot. So there is an opportunity to blend humans and AI to deliver this sort of frictionless conversations that we've all been annoyed with when we call the contact center, to deliver much more seamless and delightful experience. So there's a lot to be done, obviously, and we are still scratching the surface, so to speak, even after 20 years.